Let's take a look at the IGCSE Core Text. This is for Year 11 and 10 extension classes, Year 10 extension, and this is exercise 17B, and we're doing simultaneous equations. And I've just been asked a really great question. It's question 11, and question 11 says, a motorboat travels at 12 kilometers per hour upstream against the current and 18 kilometers per hour downstream with the current. Find the speed of the current and the speed of the motorboat in still water. So let's take a look at this. I'd like to draw it actually out. So here is my river. Here we go. And we've got a motorboat heading uphill. Now, oh, by the way, the stream, by the way, is going this direction here. That's the direction of the water. Now I'm going to have a motorboat. Here's my motorboat. Looks more like a bullet, but it is nonetheless going in this direction here. It's actually fighting against the current. That's a bit out of focus. Let's see if I can focus. Oh, that's gone off focus. That's great. So the boat here, in this case, is going. So we know the boat, this height came, is going against the current. So we've got the boat, and it's going against its boat minus the current is going at 12 kilometers per hour. And if we were going the other way, let's take the boat this way this time. Here it is. And the boat, in this case, is now speeding down here, and it's going much faster now because it's going with the current. The boat plus the current, I've got boat plus current, is going at 18 kilometers per hour. So we need to combine these two in simultaneous fashion. So I'm just going to add these together. So I've got C minus C. I'll pop this one here underneath this one. I'll call this equation 1, by the way. This is equation 2. Here's equation 2 and equation 1. Doesn't matter which order I get them in, but I'm going to add them together. So I've got a B and a B. That's going to be 2B. I'm going to C and a negative C, of course, which is plus 0, and 18 and 12 is 30. So now I've got 2B is equal to 30. If I divide both sides by 2, I'm going to divide it by B then. Divided by 2, B is going to equal 15 kilometers per hour. And that's great. So now what we can do, knowing the boat is actually traveling at 15, the water is just moving it around and messing with it, that's all. And if it was in still water, it would just be going at 15 kilometers per hour. However, we need to know how fast the current's going. So if we know that the boat's actually traveling at 15, we can substitute 15 into either of these two equations. So I'm just going to pop it into the first one. So the B, in this case, I've got B minus C. Here it is, B minus C is 12. And it doesn't matter which one you put it in, by the way. It's just easier to do this one. So I'm going to plonk the 15 directly into the B here. So there it is. So B now is 15 minus C is equal to 12. So I'm going to, what am I going to do? Oh, let's subtract 15 from both sides. Minus C is that's 15. What am I doing? 15 minus 12 minus 15 is minus 3. Multiply both sides by negative 1. And, that's negative 1. And C is equal to 3 kilometers per hour. You could have done the other way. That would probably be even better. I'd say B plus C. B plus C is 18. And I'm going to make the boat, again, 15. So 15 plus C is equal to 18. I'm going to subtract 15 from both sides. And C is automatically now 3 kilometers per hour. Probably a better way of doing it. I don't have to contend with negatives. Nonetheless, though, we found the boat's going at 15. And we found that the current of the water is going at 3 kilometers per hour.